And welcome back to 2 meters to the left of Doz's television workshop, where we're looking at Matt's Gibson G101 combination organ. So a quick recap on the last episode. We have 4 keys, these ones here with little blobs of blue tack on, that are not performing as they should. The sustain and the staccato is not working. The envelope shaping and the hole on 2 of them doesn't seem to be right at all. There's no sort of smooth attack going on. So we're back into this nasty bit down here with all those capacitors that we looked at. Let's get into it. Right, now because I'm working outside, I've sort of got a reduced sort of single camera setup. So I'm hoping you can see everything. Now you may remember last time we recapped this board with all the sustain and staccato capacitors that you can sort of see down here. I think the first thing I need to do is actually go through my work and check I haven't made a mistake. Now, thankfully, we have a very comprehensive schematic which does tell us on this switching and sort of envelope shaping board, which, because obviously there's one of these for each key, but there is a very comprehensive diagram. So I think what we need to do is go and have a little look at that and come back and identify perhaps which area of this circuit corresponds to our first key. Now, by my poor musical reckoning, so that's C, D, D sharp is our first one that's not performing correctly. Now, the only thing I'm not sure of on the diagram is whether we count D sharp from the bottom here. So obviously that's D sharp 1, D sharp 2, D sharp 3. Sorry, 1, 2, yeah, 3. Or is this actually D sharp 1 and we start from here? I think the bass section is actually separate. So we're going to have possibly 2 areas of circuitry to sell. I know this sub panel that's on the top here, that is specifically for bass. So I'm thinking that this is actually D sharp 1. But we're going to find out fairly quickly, aren't we? Let's go and have a quick look at the schematic first. Okay, so we're back with our schematic. There it is. I happen to know the diode keying is on page 9. Okay, so there's our diode board. In between here are all those capacitors we changed, and the thick film units are sort of to the left-hand side. As you can see, all the circuits are more or less identical. Now, these keys are laid out. So the first one here is C3. So I don't think it takes into account the black and grey keys. I think this is just the white keys. The black and white keys, I should say, the conventional colours, if you like. So, because obviously the bass is a black whole note and a white sharp. So these aren't included. So this diode keying network here is just for our ordinary keys, and that's what we want. So the first D sharp we come to is the one we're going to be thinking about. Now, here are all the diodes that are keyed on that circuit. 34 and 34A. Now, like you say, each one of these is labelled up. So 34 and 34A are there. So that's sort of the first area we need to be looking in. And what I'm concerned about is maybe a wire off. Maybe one of these diodes playing up. But yeah, that's where we need to start. 34 and 34A. And obviously it goes up the keys. This is the bass and pedal. And then the extended bass circuit board. You can see that's the sub board that sits on the top. So I think we're at 34, 34A. And let's go and check the work around there. Okay. Okay, so obviously the higher our notes on the octave, the lower the diode switch numbers, because that's the way it's laid out. And obviously that made sense when they built it. So we want 34. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24. It's going to be under the other board. So once again, we shall remove the extended baseboard. I just want to check, you know, that we haven't lifted any print. We haven't got any broken wiring, because this wiring loom, you know, it's been around a few years now, so we should be wary of it a little bit. Okay, there we go. Ooh, we'll build the struggle bus, and we'll revisit our work. Okay, so diode 34 is going to be under there somewhere. Righty ho. Let's have a count again. 1, 2, 3. 31, 2, 3, 4. So we're right up in this last area, as of course we would be. Right. So I must apologise for the lighting as well in here. It's not very good, is it? So let's have a look and see if we can find any wires that have popped up. And once again, you can't really see because it's behind the board. Maybe I'll just confirm that to you on the camera now. Yeah, no, they are all looking very fine indeed. Oh, hang on. No. Oh, I've got to show you this. Right. Would you look at that? It's an own goal. How many of these am I going to have? Right. Oh. So, I've just put my finger on that capacitor there. Can you see that one there? Yeah, you can. Can you see? Let me zoom in. Oh, it'll get super wobbly. Let's get a bit of light on it. Ah, there we go. Oh, yes, that's good. Oh, let me hold this board out of the way. There. That capacitor there, look. His one leg didn't make it through the board. Of course, they were a real struggle to do because that replaced a single component. So that isn't connected at one end. That'll explain why our staccato and sustain isn't working right. Good. Right, should we put that one right and then check the next one? Let me just check that's 34 first. So yeah, let's count again. 930, 1, 2, 3, 4. That is indeed. Oh, that's super news. I don't mind an own goal. Sometimes. Right, so we've got to put that right. So 34, 35, 36, you'd think, wouldn't you? No, so 35, 34, 33, 32. So 34, 33, 32. Have we got a similar fault there? Gee, by Jove, we have. As I said, that was a real struggle to get these right. I'm hoping those 4 are just operator error. Right, I am going to pause there while I put this right, and we'll come back in a minute. Okay, oh, I mean, you can see that our neon is blinking away there. So, we've made improvements, reworked some of that board, and we now got that one, medium. That's good, we can pronounce that one fit, long. Yes. This one, medium. Yes. Long. Yes. This one, medium. Yes. Long. Yes. So these 3 are Oh, now good. This one up here, still getting the wrong amount of sustain. Okay, so that's good. However, I have noticed this one is always sustaining. So we've now got a fault there. That one. Is always sustaining as well. So interesting, now it's not always sustaining. Now it is again. That's a keying issue with that key. It's okay. It's a keying issue. Okay. So that means we're going to have to do some work to the keyboard. This one is also a keying issue. So we have got a keying issue with that one, and one down here. Okay. Oh, you see it work then? Too much sustain, too much sustain, too much sustain. It's starting to work. We've got some switching issues with the keyboard. Let's investigate that. I've just removed this plate from the end of the keyboard, and to be honest, I can't really see anything. This key we know is not behaving, so there's a small screw just here. I'm just going to remove. And we're going to have a look underneath and see if what we can see. And the answer is very little. Okay, I'm going to leave that out for a second. I wonder if the switching is sort of all at the back here, under there, which necessitates a removal of all of this. Most unpleasant. I wonder if we can actually take any of that out. That looks to be a bucket of work. Let's not go there just yet. Let me just get the nut spinner and spin this little retaining plate off there. Alright, so where is the switching sort of business going on? On the back here, all we've got is a pivot and what appears to be the return spring. Although I can see a lot of wiring disappearing under here. So what happens if we lift the key mechanism out? Does that? No. No, it doesn't. Big screw there. big screw across the back. Big screw on the same on this side and across the back. And I wonder if we can take the whole shooting match out, or at least hinge it upwards. There was some sort of reference to that in the, oh, wrong way, in the service manual. So that the whole thing should be able to hinge out. I wasn't really keen on having a go at that, but hey. Well, that's really loose anyway. It's a machine thread screw. As you can see, it's quite large. And somebody's put a washer behind it. So, there we go. Washer seems to be aluminium. Now, I've done the same, oh, squeaky, same on this side, and there's a very mismatched looking screw in there. Trouble is, with this being American, these are going to be imperial threads, I'd have thought, so we may have to find some other suitable fasteners. Well, got it? Yeah, somebody's put a countersunk part in there. Still, never mind. It is what it is. So, I reckon now there's a screw coming in from the rear. So I'll make my way around here. Ah, yeah. Okay. This is the one that was stripped out from before. So, in fact, there's two of them there. And again, oh, hang on. There's one right in the bottom there. I wonder if that allows us to remove the whole instrument. Because that's bolted onto there. Yeah, all right, let's just have another look around the other side over here. Here we go. So there's another, yeah, another screw down in there. We're going to need a very big screwdriver for that. One moment, please. Right, a larger flat screwdriver. Let's see if we can ease this fella out. It's not keen. Oh, yes, got it. There's probably somebody looking in on YouTube now going, don't whatever you do undo those two big screws, Anne. It opens up a world of pain. I hope you're wrong. Crumbs, it's taking some undoing. Okay, that's got it. Let's get something magnetic to fetch it out. Gotcha. There it is. It's been out before, that's for sure. Right, I'm just going to reattach this board here. Okay. Right, now this other huge screw. That one's, again, a little bit loose. So, let's get something magnetic in there. Lovely. Now, I'm thinking, my goodness, yes, the whole shooting match is going to come out. So, oh yeah, cool. And we're stuck on something. Okay. Let's lower you down a bit so you can watch with me. Yeah, nice view of the garden while we're going down. There we go. So, yeah, it's a power supply. Okay. And that brown lead that somebody's, I think, added on, there's a lot of detritus in the bottom as well. So, and there's all the switching right underneath, you can't really see. What I'm going to do is I'm going to stop again. I'm going to disconnect this power supply, so that goes up there. So we've got, let me take you right the way down. Right, okay. We're right the way under the organ, and as you can see, there's a power supply lead going into the power supply. There's a couple of sort of, I'm not going to call them octals because I haven't counted the number of connectors, but oh, come on out. There's a couple of octal connectors, a lot of ground wires. So let's just, there's one. And yeah, it's a 9-pin, and this one is a 4-pin, I think. So just try and, yeah, it did come out quite easily. A 5-pin. There we go, good, we can't get those around the wrong way. I'm going to pop off all these grounds. I wonder if I can get that in there. Maybe not with that on. Yeah, look at that, brilliant, there's one. Not quite. Oh, that top one has no slot in it. You swines. Still I can get on that one. Ooh. Oh, all aboard the struggle bus as usual. Right, it's 2 grounds. How am I going to get on that third one? Have I got enough reach to get that in there? Not a chance. Oh, it's a struggle. I wonder if I have to use a pair of pliers on it. Suboptimal, but there we are. Yeah, he's actually coming out quite easily. Nearly, I can grip it with my fingers. Just, no, nearly, but not quite. They're quite coarse threads, so. Really? Ah, lovely. Okay. So now the idea, I think, is just to try and push all that through that hole and take the whole chassis out and take it back into the workshop. I think it's the way forward. Ooh. Right, the best laid plans of mice and men. What I've forgotten to do is obviously the output panel and this mill type socket where once would have been the pedal board needs to come out as well. Thankfully, I think I can get on that. There's 4 screws in the perimeter of it. 1, which has got instantly stuck in the end of the driver. I should remind myself not to undo it all the way. Get another driver in there. There we go. Okay, more torque. Oh, that must have been less torque. Yeah, there we go. And 1 in there. Brilliant. Okay, that one was loose. That's the output panel now detached. I think I can get away with just pushing that up through and taking the whole thing in with me. Right, let's have another go at removing the chassis. I can now get the whole chassis out, I think. I struggle with the output board, that's now inside. Power supply connectors through the hole. Come on. Right, yes. Okay. Let's bits of plastic and all sorts in here. We'll hoover that out in a minute. Let's drag the whole chassis now into the workshop. It's ever so heavy. Ah, that's one thing. Can you see if I lift that up now? Got to be a bit careful, it's a bit unsteady on its legs now. Right, here is the switching matrix on the bottom of our keyboard, and I can see that they're the same sort of spring arrangements as the others, and can also see how the sustain is possibly done. Brilliant. Well, that's fabulous news. Let's get that. Oh, I've forgotten this panel just on the left, which was for, I think one is for the volume and the other one is for pedals. So I'm going to need to remove that as well. All right, let's do that now. Yeah, the more observant of you may notice I have changed my attire. That's on account of it's late October. The clocks move tomorrow. What do they do? Go back an hour tomorrow. And the sun's just gone down outside and it's still 18 degrees. I'm sweating like a glass blower. So, yeah, let's get this chassis in here. Do you know what? I wish I'd done this originally. That's a bit easier to work on, isn't it? Oh, I wish I'd done that to start with. Wow. Right. Okay. That's going to be a bit difficult to deal with. I'm also going to want to take that out. I don't know what that is. It's not across the output. It's across something else. Maybe it's an additional volume pedal. Maybe we look at that in a bit. Yeah, let's set this down and work out quite how we're going to work on it. Because it's not very rigid without its frame, it must be said. Right. There. Back in a minute. Right, I've just been round the chassis and tightened up most of the screws that are sort of loose on it. It's definitely seen a lot of action. It's a lot more rigid now. And also, if you leave the back panel, the one with the top panel with all the oscillators on, open, makes a little stand. It's as firm as a church tied to a hedge with a piece of string, which is great. So we can work on this keyboard assembly. Now I'm just going to get a camera and zoom in here on one of the switches so you can see what is in fact happening. Okay, so as we press the key, you can see that operates this plunger here. There, look. And you can see that moves this tiny spring between two contacts. There are two contacts here. One is obviously note on, which is this front one, so we push the key, makes that circuit. And the rear one, which you can just see, it's easier if I show you there, look. Get a smaller screwdriver. You can just see that wire up behind there. Oh, I can't because my hand's in the way. Let's do this one. You can see that wire up behind there. So, which key is it? It's that one. That key there. So that spring moves between the front and the rear wires. Let's try that one. So that's what's going on. These appear to be, these are the originals, obviously. Let's move the camera a little bit so you can get a good see. There you go. These sort of plunger mechanisms here, these seem to be original, and these end ones here, which I have to say don't feel as nice, they appear to be made out of automotive crimp insulators, look. But well, whatever works, because I don't suppose we can get originals anymore. So for my next bit, my job now is to clean all the tarnish off these. Let's just have a look at the ones that we think might be giving us problems. So it's that one there. Yeah, that's very tarnished. It is that one there, wasn't it, which is very tarnished on its sustain as well, so that's good. So the note off is obviously going to control our sustain. And where's our one that doesn't really work at all right? Yeah, again, that sustain contact looks very, very tarnished. My back panel's folded in. I've got no stand anymore. There we are. It's a bit more. Lovely. So that's what's going to occupy my time for the next few minutes. I think what it's going to be is a spray and a little working gently with a toothbrush. I should do as well, I think. Okay, right, let's get into it. Okay, so that's that lot sort of spruced up a bit. Now what we need to do is work out whether that's going to make any difference. So I've got two thoughts here. I can take that out and quite quickly refit it back into the chassis outside. Or, being as I've got to repair the power supply anyway, is drop the power supply out, take the main chassis off the bench, look at the power supply, deal with that, then couple it up with this on the bench and see how it behaves. I think that's my preferred option, because if we have got further faults, there may be yet an undiscovered fault in the diode switching matrix, and I notice we've also got diodes on the sustain rail as well, so that could be, or I should say the note off rail. How many sustain is it at that point until it's gone through the switch? Yeah, I think that's going to be my preferred option, because quite simply this I can actually get out and service on the bench. I've got all my tools here. I don't have to keep running back and forward into the lounge. The only downside is you don't get to see what's going on outside in the garden. There we are. Right, let's move on with that. Right, I've removed the chassis from the bench, dropped the power supply off the bottom of the case. Quite simple, it's just four 4BA screws. Obviously we'd unplugged it all before and removed those earths. Now, what we can see here is we have a power lead coming in on this one side, and for those of you like myself who aren't really familiar with American convention on electrical wiring, their wiring has 3 cores in it, same as we have in the UK and Europe, except for their neutral is white, their live is black, and the green is the earth, whereas of course in Europe we use blue for neutral, brown for live, and green and yellow for earth. But there we are. So I'm going to remove this and put yeah, let's come back to that. I'm going to have to do something with this to make it sort of 240, and I will come back to that. So live sort of comes in here. There's a tag strip there, and it just goes off, and it then goes to the 5-pin round socket there, and all that does is connects to the on-off switch on the front panel. So the live dashes off up there, excuse me, and comes back in. There's also a pilot light, I believe is powered on that socket as well. So yeah, there's one thing that concerns me. We have neutral coming in. One, the neutral is fused. That's something they used to do in Italian electrics, fuse the neutral. I'm not sure I like that idea. So I may add another fuse holder in for live. Talking of which, actually, this is supposed to be a 1 amp slow blow fuse. It's certainly a slow blow. You can see that on camera, but there's a spring in there, which usually indicates it's a slow blow, and it is made in the USA. 1 amp, 125 volts. So that'll work fine in for the supply voltage that we need. So that's all good. That's as it should be. I don't like this soldering on here. We're going to improve this. One thing that does concern me, so that the neutral is fused, and we've got 2 neutrals coming off here. And I sort of had to think for myself as to why. One feeds a transformer primary. That's fine. And then we've got another one that feeds the 5-pin socket that goes off to the thing. And that all that does is provide a neutral for the pilot light and switch. So that's acceptable. What isn't acceptable, however, is this capacitor here. That's a suppression capacitor. And it's between live and neutral. I don't think we can trust that. I think we ought to change that out for a class X2 safety capacitor. Other things to note, this was a 500 mic 25 volt Mallory made in the USA capacitor. Somebody's glued a 470 in there and strapped it across the same line. Don't know why they sort of left that in there, really. The other thing is we've got some multi section cans. There's some writing on here, so I think these have been looked at recently. I generally found that these American ones immensely reliable, so I'm going to bet myself that these are actually all right. And certainly when the instrument is running, we've got no evidence of a hum or anything. So yeah. Then we've got our various secondaries coming out on these coloured wires here, feeding various rectifiers and going off to our multi-way plug. And there's also on the side here, there's a small transistor regulator. Let me just see if I can see the number on that. It's a 40310, whatever that is. Probably a little NPN power, maybe, I'd imagine. So yeah, let's have a quick look at the diagram now. and see what we can do. The other thing we've got to consider, like I said, is permanently changing this to 240 volt for UK use. Now, I had thought I'd found a Gibson G110 230 volt transformer. What's 10 volts between friends? Not enough to make a difference. So I purchased that for very, very little money on a famous auction site. I mean, I couldn't believe my luck. Unfortunately, it's turned up, and despite the fact it is a G101 transformer, it's not 230 volts. It's identical to this one, which I suppose is good news, because in the event of this ever failing, I've got a spare. I'd imagine what happened is somebody maybe in the 60s or 70s imported one of these instruments, decided to swap the transformer out for a 230 volt one, bought a 230 volt one, took the transformer out, put it in their thing, put the 110 one back in the box for safekeeping. And it's come back. I can't hold the eBay seller responsible for that. And it's a useful little transformer, actually. So I paid £7. So I'm not bothered about fussing around that, really. The other option is to have this rewound, but yeah, I'm not quite sure that's a sensible option either. Right, let's have a quick look at the schematic of the supply. So you can get a crick in your neck with me because it's on its side. So here we've got the AC coming in. You can see our on-off switch is interestingly sort of in the neutral line, or is this the neutral line? Because that's where our fuse is. There's 100k to ground there. Yeah, not really sure why. Oh, it probably forms part of the suppressor. There's the pilot light. So that's our extra neutral there, where this capacitor is physically mounted. So that is a 0.22 microfarads, and that's got to be our X2 class safety capacitor. So we shall find one of those and replace that anyway. Right, over here we've got these two windings here form 100 volts after these rectifiers here and here, D1 and D6. That's 100 volts, and that's smoothed by two 20 microfarad capacitors. I reckon they're going to be all right. That 100 volts is used in the neon percussion circuit. Then we have our sort of transistorized regulator. I was right, look, here's an NPN transistor, Q12. 117 volts, yeah. 100 volts to manual percussion. So these are all listed here. There's another bulk smoother there. We got 1500 microfarads on the base, good lord. 500 microfarads in the emitter, giving us 22, 20 and 16 volts LTs. Great. There's a number of earths kicking around. That, I think, is the 500 microfarads that somebody's chopped out. And that gives us negative voltages there of -5, -10 and -22. Cool. Yeah, the reason I don't want to go down the thing of getting this transformer rewound or wound for 240 is, or remanufactured for 240, I should say, is I don't actually know what's going on with these windings. There's some markings here with regards to, oh no, it's diode polarity. That's fine. But yeah, getting somebody to reproduce that is proving difficult. I have inquired, but we're not getting anywhere. So what I need to do is check the condition of these cans and chop out that 0.22 there and fit a modern X-class capacitor in there. Right, let's make that happen. Right, I've removed our old capacitor, not even X-rated, so we're not having that. I've also removed this white wire. Should have filmed this bit, shouldn't I? That went from there to that tag strip, and then the capacitor was across it. Well, you know, the march of modern technology. My new capacitor is a lot smaller than the one it replaced. So what we're going to do is electrically exactly the same. We're just going to place it between those two terminals there, or something like that, and that will be perfectly acceptable. and a lot tidier. Let's remove some of this old stuff that we're not going to need anymore as well. That piece there is now redundant. That there is now redundant. Oh, come on out. Ah, it's all coming off. All by the bit I want. Typical. Gosh. That's got it. Right, that resistor needs to go back in there, as does our lead. That resistor there is that weird 100 kilo ohms to ground. Hook that in properly. Come on. One thing you're not going to get the impression for on this YouTube video is the smell coming off this thing. The smell of sort of vintage wiring and Bakelite, and not Bakelite as such maybe, but yeah, that sort of smell is quite overpowering. Right, here's our modern capacitor, Reefer, made in Finland. I understand Reefer have now been bought by Kemet. So there we go. It's a joke we won't be able to use anymore, isn't it, really? Right, let's just see where we're going to get this to sit. I think somewhere around there will be just lovely. Just form the leads. There, that's lost a lot of clutter. And given ourselves a proper X2 rated safety component. Much improved. Right. Caution, to prevent electric shock, do not remove chassis, no user serviceable parts inside, refer servicing to qualified personnel. Failing that, give it to Dawes, he'll fix it. Right. Okay, so the next thing to do, what to do with that? I mean, it's not hurting anybody there, and it's solid as a rock. I'm tempted to leave that. Right, let's just test these is the next job, really. Okay, so yeah, I'm going to leave the power supply here, and we're going to bring the chassis back in and connect all that up. I tested these. I measured them with the old G101 ESR meter. These are sort of the LT smoothing capacitors, these two here. They're both sub 1 ohm. This one, which is the high voltage one, I'd expect that to be a little bit higher ESR. That's about 1.25 ohms. Nothing wrong with them. They can stay put. I was going to measure their value. However, in the workshop tidy up that happened the other week, I've lost one of my probes. Which is a bit sad. So I've just been onto the Peak website and I've ordered myself a new set of probes, because these are quite useful anyway. I suspect I borrowed it for something else and not put it back. I'm just having a look at the power supply actually, because I use these little plugs on the power supply, but no. So yeah, that's gone missing somewhere. So I've also ordered myself their new gold ESR meter, because I've been looking at it for ages. And yeah, I've just treated myself. Why not? So there we go. That now is complete. And yeah, that's where this episode of Doz's Television Workshop is going to come to an end. Come back for part 3. We'll get it all married up, and hopefully we're somewhere near completion. Thanks for watching, and see you very soon. Cheers now.